we've been talking a little bit about electric fields all the way through, but now we're going to go back and talk about it in a little bit more detail. So what you'll see here is similar to what I drew over here. The idea is that the field lines you draw away from a proton. And I said proton, but really I just mean any kind of positive charge. I could have a bag of positive charges, so it doesn't have to be one. It could be any amount of positive charge right there. And go ahead.
So his question is.
Oh, I think I'm going to like his question.
Yes. So his question is: if we have a moving charge that goes into the electric field, it goes like this. So his question is, where did this charge get the initial push, the force?
So we don't know, and it doesn't matter, right? We know that when it arrived here, it was going in that direction. In fact, it may be, I don't know if I should say this or not, it may be that this is actually still, and these are moving like this, and they're just moving relative to each other. In physics, we kind of don't care how things got to the state they're in right now. We care what happens after this state, what's going to happen next.
Nitan kandas jongure se deres ra ta tanda dus ta bai bana ngasuge ko phukurti tanda lora dena tsung gucho tanguyo ngasun dus ta guyores nen gucho se ti ngasuge yang ko tuichigi netan chi chago ra koge phukurti tsung gucho tanan kore phukurti de ta lora ti phang gucho tanan kores.
So there are two types of questions I guess you could be asking is what was the force that caused this to move, but also you could be asking a question of what physical machines could you create to take a proton by itself and throw it through here. So those are two kind of different questions. One is saying, I wonder what happened before, and the other one is saying, how could one create a machine to make this happen?
Da telaya joanis tayores ro tampo telaya ko tampo tengo cho kanaro chi tainas tampo shuti cheni de karinas ro ane anyo ti baina ta kondina ro chi guchu tang giya la ya guchu ti chebe cheni ge ta chuchi chi gogorwa chuchi ti ane kanne chi zoina sa chi gorwa o ti ge to ati ba ro ani chi tayores.
And the reason why I'm being very careful here and saying, like, we don't care how it got to be like this, is because there's a misconception in when people learn physics that the force of the throw somehow stays with the object. And that's not the best way to think of things.
Tanda de kas ku karege chere se la sopatela ya chi nangme tanga ge junsen sugro ata ti ku ke chem mumbi ge junsen te la ya junsen de kare se na sam sam la nga su ge ko longzun chi chi go lokto chi go res lokto chi kare se stambala ya chi tampu go bo chi ge shuti ngumbo te tanyam te de ge res ge lokto chi go res Ti manjong achete ko la yesu karige che me la so pandela kandres le me la so pate ni keche musugmares.
Because once it's moving, it's going to behave like any other positive charge that's moving in that same way.
Ta kon delal he pain baina ko dinane lokarawa dinane ku gucho tantante delal he bege netan dena do chilal he bege lokur lokmas the pudugi tak shenda chamagi gucho tan songachi ku gucho tangres.
And we don't want our ideas to be contaminated by what happened before. We want to just focus on the physics that happens here.
Ta den stambala ngasugo to no so chisade tandaga nikap de la ya ane ko ngkham ge nilu la ya ane chu chapter la so pakarin jongo yo mete tagre matopi de ge ngi netan tsula ya ne khaya chigmares.
So you could also ask the question, how did you make this proton? And that's an interesting question, but if I start talking about how this proton was made, it's really hard to understand why this is happening in this electric field. It obscures it.
Then ya chesuge gala ya puduchi to was pudude kandas tinre ya troa tena do tang deba yana tang asugo pudude industry dena ro la deshe jada ba imbaina tandang asugo nyu mixach gorwa jango sach gorwa tanda rawa dena la ya puduchin guchu kandas tangre se gi netun de deshe jagala ta ko jiganda uchagro gres ku jingu drumdua gi netan chagres.
Okay. All right, so let's go back to this. So we have a positive charge here, and we draw these field lines like this. And remember, the field lines describe, if I were to place a proton right here, place a positive charge, what direction would it move?
Ta tanda de nga suga lokarawa te dusre ta tampo te la phaso tik na la ya nga suga lokarawa tanda dakta tik chawla ya dakta tik yosa te la ya ke ti ani
and here it shows that you have a proton right here, and it's in between the lines that you drew, but the lines that you drew are just giving you the general idea of what would happen, and it's showing the direction that this would go if placed in this electric field.
Tanda de la ya ko ta bana ko tanda puduchi tanda kugi rawa gi titisha ju ani gi parola ja dwa parola sha chi kundus chi nore la de ten de tusten sha ya ta tanda de la nga su ko phodu ti la shi sha pi gi rawa gi titisha ba de nga su la ya chi samlo na chi chana chi ten gi titisha yo res.
So one of the things that's really important to talk about is an idea of the source of the electric field and then the thing that's receiving it. So here, the way it's drawn, this is the source of the electric field and it makes the field lines, and this is what is receiving the electric field that's generated from this source.
Gua che la ya netani la ya samla tangu yores tambo imbaina lokarawati chenyetes res lokarawa trenyetes res ro ti kecham chagore nyati lokarawagi shuchinti phosati kangere dos tingi bu yores ta tanda de gi pudutila shisha pambana lokarawa trenyeti gares na pudutiris ro chimaga pudutis gorwa ta tigi lokarawa tigi trembege lokarawa shuchin phosati kangresna gangla nga su puduchi shasonga hotela pukores.
So you see all of these field lines here, and really I could erase this. I could get rid, just like that.
Yes, you can get rid of it.
I could not show you this charge and just show you the field lines that it created, and you would still know, oh, there's a source right here, and it's making this particle right here, this positively charged particle, want to go in that direction.
단단 내던 데는 로치라야 다 파조텔라 요피기 기말로 요피기 다 푸드기 르무치거라 르무티 코 수바 임바이나야 고기 라와기 라티 트리바텔라 텐데다 치카리 하쿠트 크레스나 알레 기마델라야 아니 고기 라와기 특히 종콘신도 우스라 종콘델라 텐데데 고기 라와티나 샤피기 푸크르치거라 푸드치거라 아니 티코 칠로라인도 승고쳤던 것도 세데 저런 게 시트 크레스.
So we call this the source, and we say it makes this electric field, and we say that this receives the electric field. But of course, we could look at it the opposite way and say this one's the source and this one is feeling an electric field. But usually we're only interested in what's happening to one of them. And so usually we just say, well, this is the source and this is what's receiving.
단단데 임바나가 속에 고게 부드 단데라야 전부 트셔주 텔라 텐데데 네코 데코 라와티근 종콘레스 타 라와티근 종콘 텔라 텐데데 네코가 럭고 라와티즈슈 실로라 포발라 실로라 찹로 라와가 라티티 실로라 탐 텔라 텐데데 네 강라 요피게 데 부드 텔라야 네코게 슈친데 포코레 저게나 가수도 스네시자 그레스 가수가 고아 고아테 도글라나 디코레스 가나 촌촌요사데 로카라와게 라티긴 라와긴 종콘레 텔라테네 데탄 서조고텔라야 로카라와게 슈신 포코레 람나 디크레스 고아서 도글란지 라나 디코레스 에마나 시르게 마나 가수게타 고게 슈신 티치키치글라 테고요 파티 토나 디코레스.
So it's kind of the same thing as if I were to take this and I'd say, how does the gravity of Earth affect this? And you'd say, well, it's going to pull it down. I could also say that the gravity of this is going to affect the Earth by pulling it up. But most of the time, I don't care about that. Most of the time, I care about what's going to happen to this.
단단히 라라 요피기 데이터 안에 스콜라기 바로기 텐슐라 키치샹고 바나 마소가 쳇ton 남지 가르 콜랭그레나 스콜라기 나파 요피기 잘라데 아니 마 슈첸데나 로치기 탱크도 신데시티자 그레스 가서 고아 다가나랜데 그러면 다갈랜데 그레스 데 나싱게 코기 양코 고아티 칠로 다바임바나 니 라발라 요피기 뉴보티기 스콜라 양 고기 식스 다가나게 탱고레라나 고알라나 코레스. When Namjin Benanga Sukula Kuma Tangudu say quarter Chipolanguris.
All right, so now if we were to look at this one, the source of this electric field is this negative charge right here. And if I were to cover that up, you'd still know from the field lines pointing in that there must be some bundle of negative charge here.
That's just like Kimatela in Bana, Asuge ko. Mukur Mampuchi Yopalatende, Tig Trembigarawati, Kushola Kimala Tiwala Chokodwara, the Tangures. Ta Keti Kimala Yopi Mukur Sopa de Dus Lamba in Bainayan Kuga Rawa, get Till attended the Tancharange, Ale Kimadelaya, and a Mukurching Dus, Ra, teachers to get Tot Grace.
And if I were to put a positive charge here, it would want to go in the direction that the arrows right here point at. So it would want to go in that general direction. So the positive charges will want to accelerate in the direction of the arrows, but if I had a negative charge instead of a positive charge, it will want to accelerate opposite the direction of the arrows.
Gana Yochugo Pukurti Keti Mukurchi Maina, Yanko Tandaga Rawagi Ratki Dosholaya, Nikugi Gushetang Grace.
Okay. Any questions about this?
They call it iOS.
Oh.
What's the reason behind the electric field is from the positive to negative charges?
Why does it go from positive to negative?
Yes.
That's just convention. There's no physics that tells us it has to be that way. We just had to pick a direction. And so we said, well, let's make the direction of the electric field go from positive to negative. And when we made that decision, then we knew that any positive charge in an electric field will feel a force in the direction of the electric field. So those two things have to be tied together. Once we decided how we draw these lines, that told us that any positive charge would feel a force along those lines.
Rawa rati tirwa puni mugu chola imbigi rwa pukurni mugu chola imbigi jinsen kares istambala ya jinsen yo mares te tampo tembe chis tambala ya ta tab diloj ko tembe chisha juris ta tampo ko ta tembe tampo tembe chi ta tembe chis tambala ya ane ko rawa rati te pukur shone mugu chola ins te tembe chi wala tene te ta tinanjing ga so ta te tampo tembe chi che ta tembe kari china records ta te the Logachina records, Imanata, Tamputa Chiola Tendeta, that thing as you get Tanjak Pesho Tango, the Pesho Tangaina, and the Kupukur Bana, Pukurnita, Mukur Sola Rati de Opaimbana, and the Pukur di Girawana Laya, and the Pukur Chishin of Shapa in Bana, Kugarati Kishola, Rawa Tukushola Dua, data, and the Tato de Degrees.
Other questions I think I saw.
Yagala. Allora, tanto che ti muoci tan bene, ya non ci roci tensos. Allora. Allora caso catena do siciro ci sede tanda de con guccio di sicuro ra de guccio di dus mare shas ta tange ngasu ke jenda tenane de imbaina caso ya do sigimbe 다 단단들 저런 거 가서 언니들 저런 거 당보 때문에 가서가 로라가 가서로 와. 다시 단단 계절 쪽에 주디 들어와. 고쳐 가서 계절 쪽에 와. 로라 가서 때 같은 푸니 모르서로 와. 내 그거 내라야 부드치 샤바이나 그거 고쳐 가서로 와. 로와. 때들에 당기 때는 무드치 샤바이나 야 고쳐 가서 땡도 와. 그때 누구로 와. Yes, sir. So I'm just explaining because he's asking like a mixed up question because he's considering the direction of motion is field direction. So I'm just explaining this is not the field direction; it's the direction of the motion.
Motion, yeah. Okay.
He's thinking about the other one because we have an electron.
Yeah.
It goes up.
Yeah.
So.
Yeah.
Lokarola Sansame. Da Rawala ya Sansam Yoresagorwa. So my question is there a boundary or limit of the extension of the field? For instance, for the electric field, also the gravitational field, is there a limit or the boundary?
Okay, so remember there was that r squared in the bottom of the equation for both gravitational field and electric field?
단단가 저거 텐슈도 록시 인샬라 삼로 당바인바나 그거 올라야 바타카랑 니줄 사야지 통고도 점버스도 왔어요. 바데. Yes.
So if I were to take all space and empty everything out of it, and just take a proton and put it right here. Everything else is empty. There's nothing else but a proton right here.
Tatanga so compadilla shabachero, compadina yopigi, tang you put some much lot on bachero, tombatonchazo, that the kindolaya, and put the chishaba in us.
Then it would create an electric field throughout all space. But remember I said before, it's got to be able to communicate. So if I place it right here, it will start to spread according to this field of light. It will carry that information throughout all space, but it takes a while to get to the edge of space. But as it travels, it will carry less and less, or it would put less and less force on something. So as it gets farther and farther away, that R squared makes the force super, super small if it goes very, very far away, so far away that it basically is nothing at all.
Tatanga suge, koge, chinriti la shisha pain by nanga suge, the loke, kurchio pain, that under the layer pukurchi shabarwa, pukurtila tembigi, the pukurtigi lokarawachingorwa, lokarawatila tended the shendagala shuchindongorwa, shendagala shuchindongorwa. The kit in de layer pukurchi shapa in bana, pukurtigi lokarawati certain cigarettes. Certain cinemas, certain chile, kayang show tamchilla chapkares, the chabakanshilla, coola, ten big shooty, shendagala pokorwa, in Bana Suga Tangis, Chindriti la Shishapa in Baina, and it could turn around the rope by Bana, shoot on Rugorwa. That Hachan Rampola Drubi Caps in Baina, Karsigresena, Kuga shoe poseti, Hachan Chonchon, J. Shushin Choni Mepa Tavogala, Hegrota, Tarampola Dobaina, what is Legres?
So you all understand infinity a lot better than I do, but what we say is that at infinity, the field would be zero.
The Chichibana Chesuga Karsugre, the Chichina Chesu Kutoya Yosubaris, that Natsugi in the Shijatan Chepa in Bana at infinity system, but let's semi pig that could Talas Groda. Infinity la natabe pasagoroda. Say maybe Talaya, and then our lecoresigris.
And so we'd say the same exact thing for gravity. Practically, though, there's a different answer, which is that since there's so much stuff around us, that there's a limit to how far away you are from a charge before all of the other charges kind of confuse the information.
That's a thing in Bana. Dada Quatus Chilambachero, Tongue is in Bana, Asula, the Chalos Hotel Casacola Conde, Rora. That Conde is Tambalayan who is hanging in the Shagaris, hanging in the Shagaris, and the Laya, Crucio, but Kurti, Churum, like Shushin Cassotemetry, Kurti, Shushin Cassotemetry, the Laya Tangatsugas, that's the Kuga, that on Secretary, the Sansam Chijagresta, Sansen Tela Lesona, Kugi Shushinti, Loda Jenda Shushin on Dream Dwatch or water, or taking it on Telaya Chagris.
So it's when you think about gravity and you think about our solar system, you have our sun here, but there are other gravitational forces far away, other stars that far away are exerting their own pulls. We don't feel it here because we're so close to our sun, but there's an edge to our solar system where gravity is equally pulling to the sun as pulling to other matter that's out in the universe.
Tatanga Tenshule Shisha Chikechepa in Baina, Tangasu Nesade, Nimagi, Nimichinjina de Dera, Nimichinjina de Vicas in Banangasu, Nimategi, Sukula, dus Tangor, then you make Chinjina your big good, some Tangor, that's Nimagi Cholara. That Tamba Delaya. Nimagishula Tangoris, Temanan Shingi, and then that 거기 동성 감라 옆에 그러다 바람 감라 옆에 니와 젠다 간사게 양 탱거로 스콜에 탱거로다 karma 당다 라소파게 탱거요레스 탱거 요파레다 이나야 탱거 요바게 슈디 탱거 요바게 슈디리 단당아서 니마게 수타베게 텐슈디 슈초요스타마 가서 양 저거요 말와 이마이나 양스 당아서 니마 진주게 탈레레 파이마나스 다 탄삼세지오레스 니마게 진주게 탄삼세텔레 파이마나 니마게 수라 템비게 텐슈디 땅네 젠데가 파트 템비게 텐슈디 냠바기 네 세치글 해그레스.
And we call that the edge of the gravitational boundary of our solar system.
따텔라 양아수 가르세그레스 나가서 니마 침지게 텐슈게 탄삼세그레스 탄삼.
Did that answer? I forget whose question that was. Probably more information than you wanted.
되게 제스 렌텔라 드라텔라 렌트합상에서 됐어요. Yes.
Okay, so here we just have some pictures illustrating the idea of electric fields and also really illustrating that the field lines go away from the positive charges. So up here you see a plate that we just put a bunch of positive charges on both sides, and you see the electric field lines drawn away from that.
따단다들라양 속에 로라기 답비선 가시지고 요스다. 네나나 소팅 속에다 로라 기체 시행스탄발라야 부크르기 부크네실로라 템바공 오지어와 다디 당포데 임바나 속에다 샹부지레 장부지레스 장와데 임바나 고 다식레레 노지 삼나 당바이나 아니 디나네 디기 템비기 lok라와데 카레스나 네고 다다디 임바나 고 부크로와 부크인스탄발라야 야 당마두스로데 텐예스.
And you can see this is similar to this computer drawing where you have a positive plate over here and a negatively charged plate over here. And then it shows the electric field lines going from the positive to the negative.
Tatanda okte bana ngasugita loglenane tembigi parjiche delaya ngasugi shangwe niche lele niche phajo sayambana pokurtanda baje tsujo samokurtanda baje tambalaya lokarawate pokurne mokurge sholayungores.
And they tell you that there's a positive charge on this plate and negative ones on this plate, but they didn't even have to, right? If they could have just put the two plates and you could have seen these lines and you could have figured that out.
Tatanda de bana koge shangwe ni te leblete ni gang phajo salaya pokryo patan so sal mokryo patrishan doswa. Tako trishayo mata marchinala keti ge rawage takte tus yopai manaswa. 라와기 특기 따가티로와 라티티 수요파임바나 라티키 카쇼라테네다 제 파조살라에 부코요 받는 수조살 무코요 방 이그레스.
And the way you figure it out is because of the direction of these arrows. That's how you know this side is positive and this side is negative.
다 파조살라에 부코르 담바던 수조살 무코르 담바데 가르치나 하쿠레스 담발라야 가수 라티키 나타치도가 어텔라테네 하쿠요레스.
And same thing over here. Now this is just a rod, and so you can see that instead of going all in one direction like this, it's going radially out. Well, it's kind of tough to see that, but that's what's happening. It's spreading away from the rod.
다 파조들라 임바나 가수 다치 초식라 니바도 다 다다데 임바나 가수 그 죽반도 오지 임바나 죽바티 임바나 죽바티 딱 가수 포커ton다 임바나 죽바티게네 고 상득의 초라와 상득의 초라서 그러다 상득의 초라였고 라티데 가서 고알아야 안더스탠드 네가 나타요레스.
Okay, so now we're going to talk about something a little bit different. This is starting to get into more of the applied type of discussion. This is going to lead us into circuits.
Tatanda suge gangla desijabate tantes mando chilaya desijagi instantly ngasunde la desijala tendete suge loglam yorwa loglam gokola desiyongres.
And if you think about a waterfall and how a waterfall works, often when you're studying physics, you start thinking about the difference in the potential energy between being up here and being down here.
Tatanda suge babchiti mara babikapsudu staba imbana babchiti mara babikapsudu staba imbana di chibachimara bapa sete income center ko gani samla tamba imbana 다치 땅데다 오던 샤가 바로게 네티그 니와기 쳇벌라 삼땅그레스.
Do you remember what the potential energy due to gravity is?
다 제수게 텐슐라 템비게 네티그 니와 가리면 땡게도 에사. Yes. 그래.
What? MGH, right? Okay, so the height has to be in reference to some point, right? What is the height of something? The height has to be a height relative to something else. So usually you say, my height as a person is the number that's up here minus the number that's down there. And usually we take the number that's down there just to be 0, right? Yeah.
들어와 다데 속에 네티그 니바에 만나가 속에 MGH 드레스다 디카스임바나 도세 세데 가릴라랄리고레스나 지 뒤지기 세치그레스와 다 피샤샤바나 가는 거 그거 세세 담발라야 다 거기 셀라니 가는 고 파트게 란세테로 와스 다데 도세테 가소레스 담발라야 아니 가티임바나다 그 셀라탄 투사데 레코라스 자지데네 드린 고 파트 가선도 티 도세테 타그레스.
So the thing that matters most about this equation is this height. That's what gives it the difference between up here and down here. If there was no difference in height, then talking about potential energy makes no sense. It wouldn't tell us really anything.
단다 되게 네탕 디 값에 바나가 쓰고 네티기 뉴와 개체셰피 값에 바나 되나니 개체시디 토세데레스 뒤치기 토세데와 뒤치기 토세데 메바인바이나 뒤치기 토세라 뒤치기 토세 시스템블에 토세라 체퍼 메바인바이나 네티기 뉴와 세티 개체셰요 마레스.
So over here on the waterfall, what really matters is that there's a difference in height here between the top and the bottom. When we're talking about trying to get charges to move, what makes a difference is that what's most important is the difference between how much of a positive charge is on this side versus how much of a negative charge is on this side.
단다가 소 추게 텐시가 들라 개체셰 담발라야 텐슈 탄데비기다 밥치마람 바바티 바나 바치마라 고기 바치가 땅데다 워든 샤 바루게 아니 도세게 쳇प्र가서 진도세 데라 텐데다 네 바치티 콜렌 데시자그레스 텐슈라 텐네로와 데나 신경 가서게 다 로데라 타바임바나 로크 타코치 loke nibachroa loke nibatin dese jabe kapsimbana ganda won shag parola ta tanda de bana de ganda won shag parola ya ane pudta pukurta mukur niga parogi chepa kasorendu de tagres.
Okay, so when we look at this side over here at this waterfall, and you think about the potential energy that the water has at the top, what are you going to use for the mass?
Tadana de Kasimana Ranga Suguchi, Tigi, Babchitila Shisha, Pananga Suganiti, Niwaki, Niti, Nuana Langa Sukarigo, Desegodua. And they can say, Desekaripachan gave this.
One, but yet, how much water is that? How much, if you were to measure the mass up here, how would you do that?
That they like the sugar desero, sugar desero says, not Chumalo Kasuka desetagging base. Sugar desero, that you Katsuka desetagging base corta.
So if I were at the top of the waterfall and I were to dive in, I wanted to jump into the bottom, the reservoir there, right? You would just use my mass to calculate the mass of my potential energy, to calculate my potential energy, right?
The case is wrong. I got the ma wall. I should be one to down by nas. Tangala Nyangas pull a poppy, native knew what it's have by manager and Garanga to separate and digger was. That under the Kasanga to sugar dissipation tango or rather. That sugar dissipate Karila Shisha that the Peshatangi base, sugar the city.
So what? Sorry, go ahead. You can.
Tate desete chugi desete kangela shishakin base korda.
What's the problem with the? The problem is with the waterfall that there's not just a discrete unit that you can take of water.
Tanda delaya mambuska desijasra. Tanda dinane delaya sugu chuti babchutila shisha by mana bachutilaya ala tengi chin dinachigre kabuchigras. He is saying maybe relevant, I think. He's saying like the amount of water fall in 1 second.
Yeah, you could do that. You could say how much water is falling in 1 second and try and find the mass that is. And then you would say, oh, here is the mass per unit time that's falling.
Teaching degrees tanda gila sombana shengi tanda karchachkana telichuka sochimbabudusta karchachkana chimbaba tigi dutila shisha dete ne kogen nitigi bandina dogres samotana degrees.
Yeah, that's a good idea. Another thing that you can do is look at this and almost think about it as every single water molecule and figure out exactly how much mass is in one molecule of water.
Then I'm saying, Banagasu, young Shendachila, some carton or Sena, that under the Capsico Chugi did the really la Samatana de Cores, Chun did the really la Samatana, Chun did the really get the Secario, but there's Samatana degrees.
And then, if I know how much mass is in one molecule, then I could say that the potential energy per molecule is a certain amount. And I would know that because I knew the mass of the water molecule.
Now, that the young Tishi Shapa in Banachara Karisana degreesana, Chugan did the rege, any native Nuban dinner Astra, two slamna degrees, Rata, Chugin did the rege, native Nuba chaplain the nature in those decision degrees. The Shana Dubig Jensekares and Chugan did the Chilaya. And the
reason why you might want to talk about that is because the water doesn't have any other kind of discrete chunk that will be the same that you can look at.
Tate Peshetan Chobage Jensen Segorwada, Dinga Solaya, Tatanda Bana Chugun did the Rere system Balaya, Chugun did the Rere, Chugun Wood Soyagi, that could Tripchon Shiterwa, Tomato Petili Chuachila, Dinachilaya, Chugun Wu or Sessa Dumarwa, Mr. Chugun did the Chilaya, and a cook did set on Mambush and Shaban, Samala Chapi Chechuti or Istanbul to Peshetan the chorus.
Okay, so the reason why I spent so long just going over that is because it's the same thing we have to do over here when talking about charges moving.
That under positive Langasug did you move on the sugar, did you move on the connecting one decision on the Jensentica in Sena, social salataba in Bana, Masutit on Sonvi Ganlaya, and a Koga Lokurti Juguyores.
Okay, so what's happening over here is you have a positive side and a negative side, and you have these charges that are wanting to go move in this direction. And so when we talk about potential energy, it's hard to talk about potential energy because there's lots of separate charges, like there's lots of separate water droplets. So instead of talking about potential energy, we talk about something called potential, just potential. And potential is the potential energy per unit charge.
다 단다 데라야가 속에 다 파조텔라야 춘 디드리레길 네트기 니바가 콜라 케체 셰버와 네 셰스탐발라야 지춘 용게 네트기 니바테 셰 카보치긴 와스테 나싱게 데라임바이나야 코 로코르트스 망보 크 망보요 스탐발라야 코게 다 네트기 니바텔라야 살로마탄제 아니델라야 포텐셜 럭도 니바 록니 랑고올라야 decisions. Logni system balaya, logni system baldi karsagore sena local rege, any tanda de kasimbana, the locuni basagorwa, local rege, any native nibatela kugures.
So over here, when we say potential energy, we might want to say potential energy per unit mass because of the way water is. Over here, we say potential energy per unit charge because of the way the charges are.
다 파조텔라가 속에 지 탄슈크 값이 임바나 데체 니진 치키스라다 데체기 지시치키나라야 아니 네트기 니바가서 요메티 파조텔레 두스 데시자그레스 나 처전델라야 가수가 로크니오 케체션스 담발라야 아니 로컬 레레기 아니 네트기 니바사 로컬 레레기 롱니 데시자그레스
And potential energy per unit charge, we just call electric potential.
단다다 크르레레라 뎀베게 로케 네트그 니바텔라야 가수가 록니스그레스.
And we would call the difference between this top and this bottom the potential difference or electric potential difference.
다디 디스탐발라야 간다 원샤게 록니기 쳬버텔라야 로아 록니기 쳬버텔라야 가수가 록니기 쳬버스그레스.
And then this gives some examples of that with different types of battery, because batteries can store that potential difference. Batteries are like the top of the waterfall and the bottom of the waterfall.
Logmen yorwa logmen dina do kashi chingdu spitsen chisha yes tarwa digi kar logmen digi kashigala na lokke niwa gi chapters kura potential difference ta lokke niwa tindu sonerjit kyores tade baina ta dig kwandi kandaslang kores na ngasuge nitu gi niwa la shisha paim bana ni babchiti gi gota ma babchiti gi seta ani sham nisha gi nitu gi niwa gi chapters kurwa otin nanseng kwala na digres.
And also here, the top and the bottom of the waterfall, top and bottom of waterfall, and top and bottom of waterfall.
That is endala tapa imbana tada ngasuge babchi imbana babchi ki seta won shage parogi chapati ne tanda ge logmen de takana ne du songyores.
And this, I think we've already talked about this idea, but here you have potential energy of a mass, and if you were to cut this spring, its potential energy would turn into kinetic energy and could actually do some work. And over here, it's the same type of idea as if you have a proton over here, an electron over here, and you cut it, then the positive charge will gain kinetic energy and strike this negative charge.
Tangasu tenshik to lok rawa dela tapa imbana ne tenshik na neshesu haku resta dela ya nyubuti yara ko ya tende bekapsa kola ya netigu nibachi orwa ta kola ya patenchu ko tabati cheba imbana netigu nibati ngushku niba lanjur de ta kuma yong de ta tikala ya ko dongo do orwa te nanshingi tandanga so lola samna tang ba imbana gangla ya mukhur chiche ola ya pukur chido orwa ta dela ya ngasu kari orela na lokke logniti ores tanga su kuma tenche ko te cheba imbana ne logniti ko ngushku ni wala lanjur de ti ane ko ya gangla yo pigi mukhur ti ga ya kore jernugres.
Okay, so this is talking again about potential energy. Try and keep different in your head the difference between potential energy and potential because we'll use both of them.
Tata de yang senga suge karsa nitu ni wa tang ni ba lok ni sa chi garwa de ki capresa yes tata de nga suge ni chat skte ni chat pechu tang res.
So this is talking about how you can store energy as potential energy. So if I had a spring and I compressed it, right, I was like, and I cranked it shut, there would be potential energy stored in that spring.
Tata de ga la ya Pichisha by Nagasuga Dam Sugar Court Spring Ra Damsim Bana, Damsit Bajatan by Bana, Bajatan de Nikuga Nalaya, Nitugni Vachinia Sochigores.
And same thing here, if I had a bag of positive charge and I had a proton and I tried to really push that proton or that positive charge closer to the bag of charge, I could store potential energy that way.
Tagange density on Somi Ganegala Pukurgi dus Mampuyo Pache, Tigi Shola Yangarangu Pukur Jenda Chimbachada by Bana, Tiganalaya, Nikugi Nubatinia Sochigores.
And in both of those cases, I had to use my own muscles in order to do it, right? So that means that there had to be some sort of work. I had to put a force through some distance in order to store that energy. I had to put work into the system. Okay. All right, here's another example. Same type of idea, but this time I'm not doing the pushing. This time the battery is doing the pushing. And so on this side, positive charges are stored, and on this side, negative charges. And the accumulation of them is a way we can store electrical energy. That's called a capacitor.
Tata de Pajosalaya, Nipocorte salt, Sosalaya, Mukurti sos Nambalaya, and Delatin de Dinga Sugalokoni, what is hot cures, the Delaya locker sochi segres.
And all right, that's it for this one. All right, now we're going to jump to a new chapter.
Tangasul Linsagenda Chetagins, Linsagenda Chonchagins, Chetsumi Kashi Chonchajana Yasata, Chorma meet some dish.
I feel like I should play intermission music. Do they know what that is? You all know what that means?
Yes. Maybe we need the intermission dance music. They need to stand up and move around. And you to know your land, the passages cut. She said you could and you couldn't do that. And you might come as a birthday to that, the like it's your Ha, Amikashi Nishina so could do that. Ah, there. Zazachisha, Mission Apoconi is Zazachisha. Nanga do a show.
Okay, so now, when you go to a play in the States or something, a performance, and they give you an intermission halfway through, and the way they tell you it's time to like take your seat and be quiet is they flick the lights on and off. And so I don't have them close to me, but I want to flick them on and off. Do they do that here at all? If they're telling you like it's time to sit down or something, turn on the lights? No.
Pagina by Nara, that she's on the road, so she by a paru percentage on Tambalaya. Nesu just got a paru Nasu to she just Tambalaya, low purchase, she didn't do chiggers. The chasing the la carchiggers. Lost a cheaper, she didn't chiggers. No.
No. Okay. All right. Well, let's get started on electric currents. So before I get started, we've been talking about this idea of batteries and this being similar to a waterfall, where this is like the top of a waterfall, this is like the bottom of the waterfall. When I talk about batteries, when talking about current, I always talk about or think about batteries as wanting to put pressure on electrons. So electrons are the things that are going to be moving, and the batteries are what's making them want to move. And it's as though they're putting pressure on the electrons to go all the way around the circuit.
Dada nga suge delaya logmen chi yes ta logmen ko kese chance tambala ya phajo sate nga suge babchiti la samna tamba mana babchi ke che phajo sate che sujo sate ko go da wachila samna tana digores ta namje bana ta nga suge logmen kese chance tambala la lojingo ko kese che kores ro lok jinchi yo pa kese che kores ta de kese che on becomes logmen te nga namje kanda da wachila samna tanga wala na chi loknanida nonshinda uchila samtang is tarwa ta logmen tige nonshi de latene dete loglam de la yopiga lokkorte jochi yores ta ko bijaqtang yote lokkorte jochi yores.
And there are electrons all the way through here. Everywhere along this wire there are electrons.
Ta tanda tige lokko tige loglam de la yopiga lokko samata ba imbana lokko ge ta ko chashi kanzala ya lokde yores.
So with the waterfall, was it just the water toward the top that wanted to fall, or did all of the water on the way down also want to fall?
Tanga suge babchitila samna tamba imbana babchitike sela yopigi chuti chipu chimaram bamji tugu yorwe yana babchitike taku kanzala chapigi chuti kanza maram bamji tugu yores. Kaga banji tugu yores. Sela danjite banji tugu yores, sama banji tugu yores ma. Yeah, all.
All of them do, right? It doesn't matter if they're at the top or toward the bottom. Every point along the way, they all want it to fall. The same thing happens here. What I miss?
They say only the water on the top. The water.
If I took water and I released it halfway, it would want to fall, right?
Yeah, gane mas paru le na kuma babgurwas. The tanda dinga suchita babchitela samutana gana yopa paru la yopa ta mara sala matu pata sama mabaji to gorwada. Oti nanjin de la tares.
Yeah. So electrons here want to move to the bottom. Electrons here want to move to the bottom. All of the electrons are kind of in a line, all wanting to move around.
Tanda dela yopige, lolam dela yopige, lokundina na yopige. A lot of sama imbana kungochatan to grace.
So when you connect the battery, it doesn't matter where the electron starts. All of them at once want to go closer to this negative side.
Anta tanda dela ya ko tanda ke logdo digi loglam logmen digi thala ya loglam dinga su thu japa imbaina ta ko logdo ko yopigi nisale cheme gane chama nyamtang ko churin to grace.
If it weren't that way, an electron would leave here and just bump into another electron, right? It would start moving and then it would just bump in, right? They all are kind of going around. They all want to move at the same time.
That's a cool. Some Yamton Gushutan Grace, some Yanton Gushumatana, Jabloting and Danotala Danguras, but some Yamton to Grace.
Okay, so when we talk about circuits, we talk about the battery, and we talk about the battery as though it's like a pressure, but we call it a voltage.
Tatanda delaya, Tangishabanashe, Lolam Kitchen Stambalaya, Nasuge, Lomen Kitchen Gorista, Lomen de Imbana, Tangishabanashe, Nonshina Uchilaya, Kuala and Grace.
We also talk about current, and current you can't really see very well, but current is the electrons that are moving on here.
Ta tinashe ngase delaya logjun current na login yores ta login ko login jigo ta login jigo resegres bana login dus ta bayna thongomares.
So current is the idea of how many electrons per unit time are passing a certain point.
다 login sete karesegres na ani ko titsung iching nangla 아니 로드 대충 이치게 나라야 아니 그 자충 이치게 나라로 대충 이치게 나라 자충 이치게 줄이 되다 로드 가서 친구고 세테레스.
Okay. And then there's another thing we talk about, which is resistance. And resistance we also often will draw kind of like the inside of a light bulb, and that tells you how hard it is for an electron to move in a circuit.
다제다 시바나 로글람나 젠다 치카르스나 가치테레스로 가치스나 다데 고바치니 테레스 다데 카르스고르스나 다다다디나 네바나 가수고 푸조틀라야 셰토치고 핀난기데르도와 데 카르스고르스나 고 로드 고체로 로드 고체산고 로징 고체 로징 데라야 가치니 테레스.
Okay, so this says in words a little bit of what I was trying to say before. I don't know what the question marks are for.
No question marks, but sometimes when we convert that in the safe as a PDF, some of the characters turn into question marks. So you don't.
Okay.
You can just ignore the question marks.
Okay. All right. So this just tells us that current is the rate of the charge flow. And when you say rate, you're talking about something per unit time. So it's how many charges per unit time are going past a certain point. And then it's also talking about voltage being the electric potential difference. And that's what I keep talking about as being almost like a pressure. And that's so it can maintain the flow in the circuit. It provides a constant pressure.
다다다들 로진 세대 가라나 로컬 드야기 인족세티 스고로 와다 코치증 이진식나 거 같이 친구고 세대에서 로진 세대 다 오체 세대 그 다티나로 지제버치야라야 준선야라야 코트치니기 니와로 지어와 디 오체데레스 다 오체데 당기 세바나징게 다 군고쳤다야라야 지 아논시쿠아나징지라 삼르탄 디고레스.
That voltage, how much pressure there is, relates to this height. So it's almost like if you have more voltage, it's almost like you have a bigger height on the waterfall.
다 단다딜라요. 다 오세 단다딜라요 오세세나 거기 다 보내다 모니 제가 바로 그 로그게 체퍼딜라야 오세세 거와. 티 강길라라글레 오세세데 간라라글레세나 나츠게 니티기 니와시 케체시온스 담발아야 니티 니와나네 토세스도와 토세텔라야 라글레스로아 다 피샤데 다 가르스고레세나 토세시 쳔보요파나 니티 니와시 초요로와 데나징 오세 초요파나 데나징 코기난게 로그니 티요 시초요 파송고레스. Oh, that is good. We need the cautions because some of them are sleepy.
I was noticing that. Usually people fall asleep after lunch.
Tuna Johnson's Chitay Vana Chesin Javla Nishunamastan, Shela Mako, and Nishugundus.
After lunch, you're really going to be asleep. All right. So let's have a question. Do you need help with what that says?
Oh, yes.
So the first one, the first two are okay, and then it says both A and B and neither A. Is that the same question?
Okay. Tadira Shemchi Jobakan Rigores, Tadidires, the air, the Eta B and Nika Drix, Eta B and Nika Mandrix, Tadi Eta B, the Eta B, Eta B. That to the chest, Nanimako. Logina, Lokachi Joashi, yes, Logina, Logment and Yatsi, yes. Drink that.
All right. Raise your hand if you think A. All right. Raise your hand if you think B. C? D?
See the D is
decided? Okay, the correct answer is A, and just A. And so electric current is the flow. It's the rate of the charges moving. So it's the flow of the electric charge. And to say that the electric current is stored in batteries would be like saying that the current of the water is stored in the height of whatever it's like on however high it is, right? And they can be related, but they're not the same thing. So the pressure that the battery pushes with can influence the current, but the current itself is just the rate of the charges moving.
Dio Maresra, Nangasugi, Lomengi, Lodging Delaya, Shuchin Tigres, Tata Decas in Banangasugi, Lodging de Lomegan, Korean Doyores, and Doyores. Doyer, Lomengi, Lodging Laya, Shuchin Tigres. Matopi, Lodging de Lomena near your Sena, the Picha Shanangatsugi, the Chibabchi in Bana, Babchiti, Kuga, Nitu, Nivati, two second on your such usage, no which is Seguris. Did the Tata de Giomaris, Hansen and Doyores.
Okay. Okay, so let's take a look at these. First, what this is showing is this is a negative side, this is a positive side, and it's not all the way connected. So this is like you're just at the bottom of the waterfall. You're just at the bottom, you have no relationship at all to the top of the waterfall. So you're just hanging out at the bottom. And the same thing would be true if you were attached to the opposite side, but not to this side. You would be just at the top, not at the bottom. And so nothing would really happen because you're just topics hanging out at the top with no bottom to go to. So it's got to look like this for it to work, where it's connected on both sides. So So here's, you can see this is a wire and it is completely connected all the way around, and you get the light to shine. And you get the same thing here on this kind of battery. Both terminals are located next to each other, but you can see it's a complete circuit and this light bulb is lit.
다 기마텔라타 바임바나 로앙아 속에 로멘티기 탈라야 두스 로코게 니셰토티 두스 투자스 담발라야 가수가 로렌 차송아 지르샤도 아텔라텐데다 니셰토티 바데요리스 니 세존데다 바임바나 가수가 양코 로멘티스 만도아치 제코 푸니도 모니 샤강라도와 고 로코게 투자스 담발라야 네코 푸니도 모니 샤강라 요바칸실라 네코 로코게 로람 차송아 트여사 엔다데기 셰토티 바데요리스.
And then this one is brighter than this one because this is a stronger battery than this one.
다 가스고 로멜라 타바임바나 셰톤 샬라 타바임바나 세조사게 셰토티게 고온 버스탐발라 장단 치와도 와서 파조다 드르바임바나 테 치와요 베게 준센데가 레시스탐발라야 로멘 샤 드르바이나 세조고 로멘티게 워세 치와요레스.
This one has 9 volts, so that tells you how strong that pressure is. And this one has 1.5, I believe. Let me check it. Yeah, 1.5 volts.
다 단단되게 코로니고 워셀레시 샤바임바나 파조사텔라야 아니 워세 직상가레스 세조산델라야 워세 구요레스.
Okay. So now let's start making circuits.
This
is like the battery, except this happens to be attached to the wall, but this is like a battery. And then you can go through here, and you can see that you have a light bulb right here, and you have a switch right here, and this switch will open and close the circuit, so that's how you turn it on and off.
Local Jonkon said it, and as soon as Jim Banataco, local Susan was on the Santa Coris to Pagala Berwa. That is some gender town by Banagasuge, a Lomenda will Samlatan and Coris. That is so young call the Chetochulatur, the Sir Stambalanga, so Logula Tusharis, the Logotico Kashita Jai Angorwa.
Okay, and then every time you have a light bulb, there is a resistor on the inside of a light bulb, and that means that there's some resistance to the current going through. There's something that's pushing back a little bit so that it doesn't flow as easily. And so you can see here that there's a light bulb, and there's a light bulb. This light bulb has some resistance to it.
Ngasuga sheto na jibikasu ibana lolam tigi nane sheto yona ne tigi lojun tila ya gachi yo reswa ngasuga sheto sayate namje gachi tang kwala super reswa tigi ko ti sayate gachi sena kasu bersena lojun ti ko lilau gangne ju machigala ngoko yo res.
And over here you can see there are 2 light bulbs, and so if there are 2 light bulbs, then each one of them has a resistance that it's adding to the circuit. Okay, so I love this right here that tells you how all of this works.
Login tang wo se tang dichgoro wosichgoro data ka parola ya joka to Canada which you mete de la jiparich tension yes.
Okay, so suppose this is a long tube, right? And you want, or a long piece of wire, and you want to push the electrons through, all right? And so how many electrons you push through here per second? That's going to give you the overall current. So you're trying to push the electrons through, and what's doing the pushing is the battery. That's the voltage. But then you have resistance over here, making it harder for the electrons to move through.
Tata de la samtang by bana super de la samtang by bana tangasuge to shoot attended the voltage row was attended the ane of the lojun ti surgical wa lojun sena nga su ge khurgi joy marwa khurgi joy ge chedwa oti sartang yores ta keti chorong ge ta lokon dina ro chikana de jiba jigu yo pa bana pajotela wose te che wose tela ten ta nga su go lojun chusra yong gorwa lojun chu yong gores 다 되게 강라야 가서 고수용 거도와 고수 되게 네 로준티 네고 판로야라야 네고게 각기요레스 제지요레스.
So here's the equation of this. The rate of the charge flow equals how hard you're pushing on the charges divided by how hard the circuit is resisting that motion.
Tanda dila taba imbana ngasuge logenti system bala kurgi jwati katsure sana logenti ane kangetan songre sana kuge wose katsuchire shasta ko shukatsu majatang du sa chiyorwa tete ane gangla ya goshi chiyorwa goshi ki go batan songyores.
So this is called Ohm's law, and you can sometimes see it in other forms by doing algebra to rearrange this, but this conceptually is the way to think about it.
Tanda dela ya ngasugo omge tantrum sigres ro omge tantrum sigres tanda dela ya ani chitangi bana ngasuge ta chi samlu tangtang bana ko omge tantrum te distande dosres dela ya choronge sapsuge peshe tanga deta ko ga namba mando de dra yongres bana omge tantrum te chitang ko alne tan de ganem gores.
This is the current you get, and it's a result of how hard you push divided by how hard you're being resisted.
Tanda de karesena logente kangetan songresena logente ane koge shukatsuchi jagdo tete ane neko katsuchi kon gokodu se te go bada songyores.
Okay, so when we talk about circuits, we're in more of a practical science than the rest of physics. It's not as fundamental as the rest of physics because it's very practical. It's more like engineering or building circuits.
Ta login bana login de kise system bala namje ngasuga namja ta de but namje ka korli ta de bana ngasuga chi lakhtar ta chi karsa pechungela ta chi korwa ti ta de wasi choyong gres.
So this is explaining how things work on a practical level. It isn't really about a fundamental law of the universe.
Tanda de kare system bala ngasuga chi chep ke ane jisige namja chigli ane namje bana ngasu tong suge tachi lakhtar chi tambala lekha kana ro chi chigin du sa chigro lojing lekha chi tan te tan dewa chigres.
So Ohm's law, this is Ohm's law, and Ohm's law is very important. It allows us to do a lot of things, but it's not at the same level as like Newton's laws. It's not as fundamental.
Tanda omge tantrum de bana ngasula ya te ko ke chembo kechembo ibade kalana ko ngasuge lotan debe ge lekha mampuchi chistambala ya omge tantrum de ko tengu yores ro imbai na ya ko 지금 neutron ge tantrum na se yongla chapas ko ra ko register ge ngo chro tena do chi mares.
For everyday circuits that we make, this law works fine, but this law does not work for some materials.
Ta namjing atsuge pechu tangya ge chi loglam namjing atsuge chuatan dewe ge loglam le bana ta da onge tamchin de pechu tangna ko pechu tantki ores imba na ya tanda ge dela ya tantrum stoga tantrum de ya ko jang khashi chila ya ko pechu drusan du mares nguji jenda khashi chila pechu longo mares.
So we're going to be pretending like this works for our purposes, but it's not a fundamental law. It's just a usually right rule.
Then did nga suge kandachilang gunjin chingin sena nga su namjing gita chi suge nang ne pechu tons nambala pechu yom bakanshila ane chi chilla miche parwa mangajit machirwa ne namjing bana nga suge chingdi pechu tang bayana ku chitapte te tata yong ko yopai nambachila ya ane gunjin chigis.
to give that answer to. All right. It says both A and B and neither A nor B. This is both, this is neither.
C team bana A tang B ni chandikioris D bana A tang B ni kan maris goris. Tin de no chakono ko jinsen kari.
Alright, can I give you a hint?
This one is just done with this. They are done. They said they are
they're done. Okay. How many think A?
A is yes.
Okay. B.
B is yes.
C.
C is yes.
D.
D is yes.
Okay. So the correct answer is A, current. And this is why. If you're doubling the voltage, that means you're putting in a battery that's twice as strong, right? That means you're pushing twice as hard. So if you're pushing twice as hard, go back to the cartoon, right? You're pushing twice as hard, you're going to increase the current. Okay, so you know you're going to increase the current. So now what about the resistor? Well, the resistor is a property of whatever you're using. So if it's a light bulb that is doing the resistance, it's a property of the light bulb. It has nothing to do with using a better battery. The resistance is the resistance of the light bulb. It actually comes from the coils in there.
kun rosa ga lamka tiki chechurwa tanda de bana nga suge digi sheto digi chechurwa ko kari imbate de degrwa no mares.
Sometimes you want to add an extra resistor to a circuit. There are different reasons why you might want to do that. And then they look like these. These are pictures of actual resistors, things that slow it down. So it's a property of the device that you have in the circuit. It has nothing to do with the battery.
Tako gaksi dina rosha pa na kola chechi goroda goshi chi goroda o titi korang yubo de chechure matopi te tang tukka japchu gi lokmen la sokola royo mares.
Okay, so this one's talking about power, electric power. And if you remember from before talking about power, power is the rate at which you're changing energy. So in this case, we're taking, in a circuit, you're taking the energy, the electrical energy, and converting it maybe in the light bulb to light and heat. So there's a certain amount of power that is being put out by the light bulb.
That the loctobres power what they call an alokaniwatin ngula gendalaya jurugi setres that ngasuga shetochi imbana shetoti parwa imbana shetoti ngasuga lokaniwatin niwa genda ngula jurguyorwa.
And so the formula for power is power equals current times voltage.
That loctobte cares and a loctote logente was a jurata songores.
It looked like that was maybe not communicated on the slide, so. Okay, so now let's talk very quickly about two different types of current. Yeah, let's do it on this page. Okay. I'm sorry, two different types of voltage, so, or how you get power. One is through batteries, and I've been talking as though a battery is the only way to supply that pressure.
That and the Layanga was set the Jeopardy number mando and you got a shagins, Tangi Banangaso, that the capsule Bana, Login the George or like no Shikung window, Chipayans, Delaya, Nasugi would say, than the Dickers are Lomengi, any Kogan non shitty, non shikura, Tangasuti, Jeopardy at the Lomenti pictures of yours.
But there are other ways of getting power and supplying that voltage. And that's if you have power delivered directly into a wall or outlet without a battery.
That's the thing. So, what's it? This Japanese city, long mention, and then Maranga looking at Shajakuro, Aneko Karsa, Loti, Timbatina race.
And so the way that works is instead of having a battery, you would just plug your circuit directly into an outlet. Because of the way that the power is generated, when it comes in through the wall outlet, it's called alternating current because it sloshes back and forth. So here's kind of a picture of the difference between the two. If you have a battery, it's just constantly going to be pushing in the same direction. And then down below you have alternating current, which is what comes out of the wall. And that actually pushes back and forth. It like pushes and pulls. So it pushes the electrons, then it pulls them back, and then it pushes, and then it pulls, and it goes back and forth. And that's okay. A light bulb doesn't care which way the electrons go back and forth. A light bulb works because there are electrons going, moving. It doesn't care which direction it's moving.
de pando sundu de netandela ya ko choyo mars gashila bana ngasoge sheto imbana lodoti goche tangna kores ko phang goche tangna ko sangoje kanda goche tango yores goche te pha tang chotang tela ya ko tengmares.
And that's okay because the light bulb doesn't care, but my computer very much cares. My computer cares which direction the electrons are going and doesn't like for them to be sloshing back and forth.
Tada nga su lokke de imbaina ro nga su lokke de imbaina shetoke tanda lokde tige gocho ko khasutela ya koge ya chig maris name tangres ko gocho yona de kores imbaina ya tangaranga lokle tawla chomba imbaina loglege ta ko gocho te ko 판도 처용 바이나 로드티 판도 처용 바이나 텔라야 네 야치그레스 네 저 바이나 가우치 말레스.
Right now it's running on the battery, and so that's fine because that's just a constant like that. But when it's plugged into the wall, it would have the current sloshed back and forth, and it can't operate like that. And that's what a block like this is for. It's to make it look more like that.
Tadanga ranga logle de padu sijabe kapse bana ko nala yopigi logmen la tende de ton kole kachigi yores logmen la tende de le kachigi yopa embana ta ko login te ko tembu ngo la yoro ko peji login yo mar teji login ngo la yores ta ko shaja produce logla la chupa embana ko peji ko login ngo stambala ti gane le kata ta chit kamares le ka chit kmecha tanda de la ngasuge ko losoche ko lothas doa lothati ge parola ya dodos doa dodo tige karchigo resena peji login te yara teji login ngo la ya tembu ngo la zugo yores.
And alternating current works different here than it does in the United States, which is why whenever I travel, I have to bring converters in order to plug into the wall to get my electronics to work.
Tadanda de la peji login bana peji login ge chech gorwa tanda ngasugo chech gorwa tete ari tang jagan chalaya tes ko ragmecha ane nga dusun rejiyo be kapse yang ko pansula jijir chini ge yuchi tinda yang kiyong ge yos.
Yeah. This is actually better. It's better. It would be better if the US were set up like you have it here.
Da leka chitang bana ko ga lok roksi leka chitang bana da de la yat sujong de la yan dir do ni jata shichur do dim bana shirge na ko leka chitang thane diu yores yapu yores ta kete arela yan din ajin sujong din aj pechitang yo bana da tele yores.
But once you have a standard, it's just hard to change.
Ta ko namjin ko ta chi jin tengi 지금 세등은 오지를 했담발라 세등은 오라 야탄을 했담발라 연 지라탄 카보 정교레스.
Okay, so we've already talked about each of these types of ideas, but this tells you what the symbol is. So if I'm talking about a circuit and I want to talk about a battery, I draw it like this. If there's just a wire connecting something, it's just a straight wire like this. A resistor, I draw up and down, it looks like the inside of a light bulb. That's how I draw a light bulb, and that's how I draw a switch.
Tadanda gala yopige te loglam ge lokna ge yoche dezo cha ngola chesula deshe chitsares ta wala yopate ngasuge ta tab diu gane loglam ga remote stambala kandas choma santeres ta tampote bana 내가 가지고 롱맨 첨바 타켓 바나 로코 첨바 치조테 바나 가지고 같이도 첨바와 되게 치조되게 셰토도 첨바 치조 내가 가지고 로고 첨고요레스.
Okay, so after lunch we're going to talk about two types of circuits and then we're going to talk about magnetism. So one more question before you go, which is, are you hungry?
Yangonga jabla yanga suge loglam manda ni yoreswa loglam manda ni yore tikola ya desijab tige jela yanga suge carbon kola desijagis tate mapheng wala droch yes drote kare system wala toko toko does
Yeah. All right, let's have lunch.
So